Okay, 5.6. Some people are scared of it for some reason. At the end of the chapters, there's always this cloud of confusion because all the word problems come out to play. But if you can visualize trig, you can visualize math. That's why it's so important to use colors and use graphs, because if you can visualize things, equations are easy, as long as you know how to create them from the visualization. So that's why we have to grind that graphing, graph everything. The more you graph, the more you can visualize better, and the more you can solve things. So let's take a look at this. Look how ugly this is. So first of all, this is using trig to model periodic functions that don't involve angles. We're not talking about a terminal R anymore. We're talking about nature has periodic behavior, and we want to model it using an equation. For instance, the sun rising and setting. That's periodic, happens every 24 hours in the same manner, plus or minus, the rotation of the Earth or the tilt, whatever it is, or the position of the sun, sorry. Waves, if you go surfing, if you ever go on vacation to Portugal or Costa Rica, the high tide and low tides are different. It's periodic though, because the high tide comes back every so often. Low tide comes back every so often. So whenever we don't involve angles, there's honestly not much else we need to do. We can kind of pretend that this doesn't exist. Who cares? It doesn't involve angles. Nothing changes. Except your k value might be whack, because it's not going to be like a 3 or a 4. It might be like 1,000, might be 1 over 1,000. It could be anything, depending on the periodic function. If we're talking about 24 hours is one period, we've never dealt with a period of 24. It's always 120, 360, 180, stuff like that. But anyways, I want to convert this boring thing right here, which is a table. Nothing's worse than a table in math. It is so boring, and we have to come up with an equation for this table. Okay, so there's not even a question here, but I'm just going to come up with an equation. I'm only going to do this question for this section, and hopefully it can clear up pretty much everything. You want to come up with a table, an equation, start with A and C. A and C for life. I want to visualize my lines. I'm always going to go back to these guys. I want to visualize these. I don't have to write it down, but I want to visualize them. If I can know the max and the min, I know A and I know C. I'm 50% done with something that requires a grade 9 math skill. I'm looking for my max and my min. Here's my min. Here's my max. So I'm just looking in the numbers. Like, this is the x value. These are the x values, 0 to 23. These are the y values. That's the lowest one. Well, that's the highest one. And then I don't care about the next one because I can use periodic behavior to figure out the rest. Now, the minimum happens at 1, right? Sorry, is 1.8 rather. Minimum, 1.8. Maximum, 46. A value, I can do 46 plus this divided by 2, midpoint. So let's do it over here. A equals 46 plus 1.8 divided by 2. I don't know if I showed you this hack, but if they're both even, I'm actually going to be thinking of 23 plus 0.9. I'm going to divide both by 2. Instead of going to like 47.8 and dividing by 2 in my head, that hurts. But this is really easy, 23.9. A, done. No, sorry, that's like the A value. That's the bounce, not the C value. Okay, this is this distance. This is A, 23.9. If I know this is 23.9, I can add it to 1.8. I can subtract it to 46, or I could just come up with the C value using the equation for the C value. So C value is max minus min divided by 2. Again, 23 minus 0.9. 23, sorry, this is the opposite actually. Oops, I'm gonna erase this. Let's just continue. That's gonna be 22.1. Sorry, half of the distance is your A value. So this is actually the A value. The midpoint, this is midpoint formula with addition, is the C value. So this is 23.9. And this is my A value. That makes sense. This is my A value. Half the distance from the max and the min, or the distance from the middle to the min, or the distance from the middle to the max, whatever you want to call it. Okay, but knowing these two formulas that differ by a plus and minus sign, obviously you can make a mistake, I just did. Really easy to find A and C. If you make a mistake with A and C and it's not the switching of the formulas, it's like a max and a min thing, you're cooked. Okay, let's come up with an equation. I know A, I know C. Do I want sine? Do I want cos? I don't know. I actually don't know yet, so what am I writing? Now, what's the k value? I can't find k without a period. I need to know the period. I need to know when it goes from minimum to minimum. I need to know where it goes from maximum to maximum. But the problem is, in word problems, is that information is not staring at you in the face, right? So you don't need to know where it goes to the next max or the next min. It's gonna be off the chart. It's gonna be somewhere over here, right? Where is it? 1.8. It's like next, I wanna say. Maybe another 2, I don't know. But if you have the max and the min, this distance, if you have these two pieces of information, this is always half of the period, because I need this again to go back to the minimum, whatever this is. So if I know the distance from the minimum to the max and I double it, that's the period. So let's take a look at that. It's a 1 and it's a 13. 13 minus 1 is 12. That's half the period. So the period is 24. Now I can find my k value. K is 360 over 24. But sir, why are you using 360 if it's not involving angles? This is how we get it out of angles. The k value is just an equation, right? So 360 divided by 24 is 15. Got my k. Knowing this, that this is half of a period from min to max, saves your life almost always, because questions tell you this is high tide, this is low tide. That's it. You know everything just by those two pieces of information, because you know the distance between them, double it to get the period. You know the max, you know the min, find A and C, and then you know where your starting point. Pick the max, pick the minimum, pick the middle, do whatever you want. Okay, that's where we're at right now. I have no space here. I got to find out my starting point now. I have everything but the D value. Hardest part for sure. But not really, because the question doesn't say use sine, use cos. If it doesn't say use sine, I'm gonna go as little looking as possible. Here's the minimum, that's where I'm starting, at 1. So I'm gonna write an equation. Y equals the A value. Why am I writing the A value? What starts at the minimum? Negative cos. So negative A value cos, K value, D value, we'll talk about in a sec, C value. So I just plugged in everything I know over here. It's negative because I'm starting at the minimum. That's why it's negative. The D value is where you started. How shifted is that? 1, minus 1, done. You want to start at the maximum? No problem. You write down everything the same, except now cos starts at the maximum, right? I would always try to start at the maximum, and if you know me, it's because I don't want to write a negative sign that I don't have to. But what's my phase shift gonna do? Well, look at the max. It's shifted 13. Okay, cool story. Minus 13. Done. These are the same. From 5.1, these differ by a period, which is 12. 1 and 13 are 12 apart. So obviously these functions are the same. One has a negative, one doesn't. If you want to come up with a sine function, there's a few ways you can do that. You can think of sine starting between the max and the min, or you can just take the period, divide it by 4, which is 3, and you can move 3 away from the max or the min to find out where sine starts. So all I really have to do is add 3 to this and add 3 to this, and I can come up with my sine function. But I don't want to confuse this video. I always use cos if I have to, and unfortunately, questions are probably going to ask you to use sine, because that's what math does. It says it goes right, it goes right, it goes right, and then boom, it goes left and it burdens you. Okay, so be aware for the guy who goes left.